Hello, and thank you for joining my presentation on passive Wi-Fi. In this presentation, we will discover why passive Wi-Fi will be the future when it comes to powering the Internet of Things. This is the overview of this report on passive Wi-Fi. Basically, we're going to talk about why we need passive Wi-Fi, how it works, what the challenges are that still are in development and will need to be addressed before it becomes a mainstream technology, the speed and technical specifications of passive Wi-Fi, and where this goes after perfection. And then finally, I'll provide references that I've used for the graphics and for the research and links for additional research if you find this topic interesting. Okay, let's look at why the Internet of Things will need passive Wi-Fi to operate. First of all, the Internet of Things is going to encompass a lot of things. It might as well be called the Internet of Everything, which in some circles it is called. You have civil opportunities, meaning basically our services, everything from the power grid, environmental monitoring, water, traffic. These will all be connected, and every device on the system will have to be powered in some way. Commercial opportunities, that's another category. Consumer supply chain, automatically stocking of the staples that you require. Basically, if you're out of laundry detergent, your washing machine can literally contact Amazon or any other retailer, can shop for the best price of your brand that you prefer. Go out, find it, order it, and have it available when next time you go to do laundry. Same thing with the consumer automation. Your HVAC, your heating, your air conditioning, the amount of power that you consume, your entertainment choices, your security to your house or your car or your business, all integrated, all moving parts, all anything that interacts with you or with these systems will be part of the Internet of Things. Problem is, the Internet of Things and all of these different systems will have to be powered. And a lot of the little things, like your washer and your dryer and your coffee pot and your refrigerator and your garage door opener, these are things that are going to require power. But the way it currently works, you can't power them with plugging them into a wall. You'd have to have a lot of rewiring of your current infrastructure. What passive Wi-Fi promises to allow is the ability to power these things with very little energy. A AA battery in most cases would power it for months. So let's continue looking at other reasons why the Internet of Things is so important and why passive Wi-Fi is so important to power the Internet of Things. So we look at how passive Wi-Fi works. It used to be that in order to get a Wi-Fi connection, you had a radio and you had a receiver, and then the other device had a radio and a receiver, and it would make a secure connection. Passive Wi-Fi gets around this power consumption by using what's called backscatter, or a Wi-Fi backscatter tag. So let's go through the process. Your router, or in this case your access point, sends an RF signal to both the Wi-Fi receiver and the passive Wi-Fi tag. The passive Wi-Fi device is still able to transmit data on the 802.11b protocol by absorbing this tone, the tone specific to whatever it's trying to communicate, and using a backscatter tag. The Wi-Fi reader interprets this and completes the required 802.11 protocols such as acknowledgments and requests, and other types of overhead required for 802.11. Basically, the backscatter tag absorbs or reflects specific information in the radio spectrum, passively denying that spectrum to be passed on to the Wi-Fi reader. The Wi-Fi reader then can interpret this and actually process the communication between it and the Wi-Fi tag, or the device that that's connected to, just as if it was on the internet or on the network itself. So, the wireless access point, using its MAC address and associating the MAC address of the Wi-Fi reader, cell phone, laptop, whatever the other device is going to be, it registers those two MAC addresses. Then the Wi-Fi backscatter tag absorbs the information or reflects that information to interrupt the communication between the 2 points. The radio receiver communicates from the Wi-Fi reader back to the Wi-Fi access point and is able to gain the information reflected. Therefore, connections and the internet network connectivity are able to be communicated without having the costly overhead of the power of the radio frequency. The key technology in this process is what's known as backscatter, or the backscatter modulator. Basically, in the graph you see below, you see the process. The backscatter modulator is the key process in allowing these reflections and or absorptions of the radio signal, and then only the digital part of the receiving card is all that's required. The digital part that requires much less power. It processes what it's received through the backscatter modulator and is able to passively communicate with other devices on the network. How much more efficient is passive Wi-Fi? Up to 10,000 times more efficient than the static connection of an analog radio to another analog radio. Look at this Wi-Fi card in this picture. The majority of this card's power consumption goes to the radio module. The radio module has to send out a constant stream of connection between points. The other part of this Wi-Fi card is the digital synthesizer. It uses much less power. And with the passive Wi-Fi, it's the only part of the Wi-Fi card that will be included. So not only do you get the power reduction, you get the manufacturing cost reduction of a much smaller footprint. And because it's much smaller, you'll also get the advantage of putting it in smaller devices, or putting it in devices and hiding it from view much more easily. So passive Wi-Fi reduces the power consumption and increases the places that you can put a connected device. However, work remains. There are a lot of technical problems that passive Wi-Fi will have to solve to be the standard for the future for Internet of Things. First of all, interference. When you are communicating by removing a signal, you're much more susceptible to interference of that signal. A lot of things can cause signal to disappear. Interference, there's a lot of naturally occurring radio waves, different noise that could interfere with the signal and cause false readings in the receiver. Second of all, is security. Obviously, with a passive system like this, there's some security concerns. Now, the receiver with the wired connection and the Wi-Fi receiver do the same security protocols and protocols as any other 802.11 standard. However, it's still a concern that someone could mimic or copy the passive device. Another real problem is latency. Because it's a passive device, it doesn't allow intercommunication as far as on its own terms. It sets to listen at specific times. So it's receiving its packets, but it's receiving its packets in a very structured way and not able to change the time that it takes. So the latency can be an issue for instant access. However, most passive devices should not require much latency. Range at this point is a concern. Obviously, the further out a radio signal is, the more scattered the range is, the more scattered the frequency. And at great distances, it's impossible. Currently, the range can get a little further than Bluetooth technology, so it's a good start. And if it continues to improve, this should easily surpass the range of other competing solutions in the power distribution problem. Existing infrastructure. At this time, most of this technology could be implemented into existing infrastructure. However, if it's going to get more sophisticated, it's going to require access points and Wi-Fi receivers that specifically understand and know how to process passive devices. Finally, multiple passive devices. The absence of a signal is very difficult to have multiple devices sharing the absence of a signal. It is possible. Each one can be on its own radio wave, and it's not something that's deemed impossible. But at this time, that technology does not exist. Should be available in the very near future. Powering the Internet of Things is going to be a challenge. Everything's going to be connected. If it interacts with a human, or if it interacts with other machines, or it interacts with the environment around us, it's all going to have to be connected to the Internet. And all of these devices, it would be impossible to connect if we didn't have some sort of power-saving technology and reduce the footprint size of the device required. Passive Wi-Fi could be, while it's still in infancy as far as the solution of these things, it could be the answer to all of our power needs for the Internet of Things. In this graph, you can see how the number of devices we communicate with have grown from just over 1 million in 1992 to over 50.1 billion estimated by the year 2020. That growth rate, if you look at the chart and you look at that line graph, you see that it's accelerating, not decelerating. The number of devices on the network and on the Internet is going to continue to increase X-fold over the next 10, 20, 30 years. And for us to be able to connect all those devices, it's going to be important that we use the passive Wi-Fi capabilities or some other technology that emulates those capabilities. Finally, I have a list of references here. If you're interested in learning more, there are some great websites here. I want to give special recognition to the Washington.edu files, the papers that I used most extensively when researching the backscatter process and the passive Wi-Fi, real scientific papers. So that's what I would urge you to visit first would be the washington.edu files. And then after that, there's a lot of other good articles for additional research if you are so interested. Okay, in conclusion, I want to thank you again for watching this